Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we will discuss about the question number 18 in this video of JEE Advanced Physics paper 2015. So let us solve the question 2015's question number 18, which is based on simple harmonic motion. Students, let us solve the question number 18, which is based on the simple harmonic motion concept. Simple harmonic motion. Basically, this is about the charges, electrostatics and SHM combination. The figure below depict two situations, you can see here, in which two infinitely long static line charges. So these are the infinite long static line charges. This is situation 1. This is another situation of constant positive line charge density lambda. So we have a situation like this. So constant positive charge. Here this is lambda coulomb per meter. That is the linear charge density of this. This is also having lambda linear charge density. This is infinitely long. This goes up to infinity. This also goes up to infinity. This side infinity. This side infinitely long. Are kept parallel to each other. These two are parallel. So these two are parallel to each other in their resulting electric field. In their resulting electric field, point charges Q and minus Q are kept in equilibrium. In one situation, plus Q is kept. In another situation, minus Q is kept in equilibrium between them. So if I consider the point, obviously it should be the midpoint, because these two lines are having equal charge density. So at only midpoint it will be in equilibrium. If I place a charge, suppose plus Q here, the force due to this will be towards right and the force due to this will be towards left. And because the distance is same, these two forces will cancel out and this will be in equilibrium. So let us first consider this one, then we will go to the second situation. Now, are kept in equilibrium between them. So here net force will be 0. The force due to the first wire and due to the second conductor will cancel out. So it will be in equilibrium. The point charges are confined to move in x direction. So this is the x direction given. So this direction is x direction. So this point charge is confined to move. It is a constant motion, that is charge cannot move here or there or in any other direction except this direction. If they are given a small displacement about their equilibrium position, so the displacement of this particle should be towards right or towards left along this direction. And if this is given a little displacement towards right or towards left along x-axis, so what will happen? The question is, if they are given a small displacement about their equilibrium position, so this is given displacement either towards right or left because the motion is confined to x direction, then the correct statements is or are, both the charges will execute simple harmonic motion, whether in both the situation the particles will have SHM. Second, both the charges will continue to move in the direction of displacement. Suppose that if I displace this in this direction, whether this will continue to move in this direction, that is in both the cases, whether they are moving in the I cap direction or minus I cap direction. Okay. Third, charges Q execute SHM. This will execute SHM, while the charge minus Q will continue to move in the direction of a displacement. So this second case says that it will move in the direction of displacement, and fourth option is the second one will execute SHM while the charge plus Q will move in the direction of displacement. So in this situation, we'll first see that due to a cylindrical or wire or cylindrical linear charge distribution of infinitely long, very long conductor, the nearby place, we know that due to a linear charge distribution of lambda, and nearby place at a distance x or at a distance r, the value of the electric field will be, if a point positive charge is kept here, then the electric field will be in this direction. So the force will be in this direction, and the electric field is given by lambda over 2 pi epsilon naught x, where x is the distance from this point to the line charges. This is a perpendicular distance. Now I can convert this to k form. So this will be, if I multiply 2 over here, 2 over there, then this will be 2. Multiplying 2 here will become 1 upon 4 pi epsilon naught, which is k lambda divided by x. X is here x. So this is the value of E that we are going to use for this situation. Again, that if I place a charge q here, this charge will experience electric field of this value if this distance is x. But in this direction, the force will be, we know that when a charge is placed in a, suppose this charge is q and the electric field it is experiencing is this, then what is the force that this experiences? The force on the charge placed in electric field is given by q into E. This formula you have to use. So in this situation, the force that this will get will be q into E because of this one, and similarly because of this one it will be in this direction q into E. This is how you solve it. But now here in this situation, when time t equals to 0, that the displacement is not happening, the total forces will cancel out. But then when this is displaced towards right, slightly given a small displacement, whether towards right by an amount, say x, very very small amount, suppose x, whether towards right or towards left, you will have the same answer. So suppose that I am displacing it towards right by an amount x. So before that we have to define what is the distance between the two wires, which is not given. Suppose that I will consider that this distance are equally placed, this charge is equally placed between the two wires. So I will consider this distance as a, where the charge is placed, and this distance is also a equidistance. So when this is shifted towards right, if this is given a displacement towards right, then the charge will be here, and in this situation you have to find the net force, what is the net force responsible for the motion. If I place it here, you can see that this distance for this conductor, this distance will be a plus x. So for this conductor, the distance will be a plus x. This charge is at a distance of a plus x because x is the displacement towards right, and for this the charge will be at a distance of a minus x. So these are the respective positions of this charge from this conductor and that conductor. So in this situation, we will have to write what force is acting because of one, that is force 1 because of this one, and force 2 is this one. So that will write, and the difference or the resultant of these two is called the net force. So the net force. So now I will consider this point charge q plus q, and because of this first conductor, the force it is acting is F1, because second conductor the force is F2. I don't know now to find that which force is greater. So first of all, that we must write the formula that this force is q into E, and E we got last time, that is 2k lambda divided by x. but here the x is basically the distance of this distance is we have considered this distance as a plus x, and for this one this distance is a minus x. So f1 will be so this divided by the distance, I like the distance d, so this formula I have to use. So for f1, the net force acting on the charge q will be f1 vector sum f1 plus f2, but because they are in the opposite directions, so one will be positive and another will be negative. So now that because f is inversely proportional to d, that means as the distance increases f will decrease, as distance increases f will decrease. So therefore if this decreases, then f will be more. That means when this charge moves towards the second conductor, the force because of this, which is F2, is greater than F1. So it is clear that F2 is greater than F1. So the net force will be towards left side. So if I want to avoid the sign convention and directly putting the positive negative sign, I can write that this F2 minus F1 will be the net force, because this one will towards left and this one towards right, and this force is greater than that. So I'll write F2. What is F2? This one, Q times 2k lambda divided by the distance. Distance is a minus x. Similarly, minus Q 2k lambda divided by d. This distance is now a plus x. What I'm doing is that I'm just substituting the value of f in both the situation. Only d will change, and that the distance is a plus x and a minus x, that I have to substitute. So if I take common this 2k lambda q, 1 upon a minus x and 1 upon a plus x. If you solve this, then what will get? Let us solve this first. The net force acting on the charge is 2k lambda q over a plus x minus a minus x divided by a plus x into a minus x. What I've done? What I've done, I have taken the LCM of this, that is a plus x and a minus x. Here it will be a plus x, here it will be a minus x. Now, if I open this, then this a will cancel out and this x will be positive 2x. So it will become 4k lambda q, because from this 2 will come and 2 and x will come, x divided by, this is a plus b, a minus b, this is a square minus b square. So because the displacement x is very very small, x is very small, very small, so the x square terms is neglected, it tends to 0 compared to a square. So that means if this number is subtracted from n naught, this is nearly equal to a square. So if I substitute this concept here, or I put this assumptions that conditions that x is very small, so it is so compared to the distance between the two parallel wires, the displacement is very small. So therefore that is you can neglect it, make it 0. Then this net force is 4k lambda q by a square into x. Toward this side negative, you can put negative positive, that is not important. That obviously in vector form it will be negative, in scalar form it is positive. So anyway, I am writing in scalar form. If you write in vector form, then toward this side, so it is negative, put this negative, no problem with that. So we know that this in vector form, okay, if you want to write in vector form, this net force is minus 4k lambda q by a square into x. So this is f is minus kx form. So any particle which follows this equation, f is equal to minus kx in vector form, then it's said to execute simple harmonic motion. So, and you can also find that comparing that omega, this is k and k, if this comparison, this will be your k, this will be your k. Okay, that is the constant, force constant. So you can find omega and all, but the question is not about to find those omega and or time period of oscillation. What is the time period of oscillation? That also you can find comparing this. This is your k, and k is m omega square. So from omega, it will be k by m under root. So this is k. If I compare with the given situation, I'm just giving you this extra information. This will be our k. This will be our k. So omega will be k is 4k lambda q divided by a square. This is your k. So under root of this, okay, this is your omega, and omega is 2 pi by t. Then you can put this value here and then find the value of time period oscillation. What is the time period oscillation of that particle? But it basically shows that this particle q, the having charge q, will perform SHM because force is proportional to minus x. Whenever force is proportional to minus x, then that motion is simple harmonic motion, so the body will oscillate. Now the second part of the question is that, now in the second part of the question it says that if minus q charge is placed, then what will happen? Now if you have a two parallel linear charge distribution as usual, as earlier, there is nothing going to change. This is lambda coulomb per meter, this is also lambda coulomb per meter. The particle is at point midpoint, and this is minus q. It will be in equilibrium because this will attract this and this will also attract this. The forces will be inward. So this is conductor 1 and this is conductor 2. Then force due to this one will be in this side. This is F1 and this is F2. So in this situation, this F1, F2 will be different directions, opposite directions. Now, if it is happened that this charge Q is slightly displaced towards right or left. Suppose that this is displaced towards right and now it is here. Then in this situation, the minus Q charge is here. Now, this again that force is QE. Q into E, that we got 2k lambda divided by the distance r, say. This is the distance or position of the point where or charge from the conductor. Now, as usual, F is inversely proportional to R. If R decreases, then F will increase. So, towards right side, if I am displacing it towards right, then this distance will decrease and this distance will decrease. So this distance will decrease, the force will increase. So the attractive force, this force F2 will increase, and this force F1 will decrease. F1 will decrease. So this will increase and this will decrease. So this point charge Q or minus Q, suppose, and this side the force is increasing, and this side the force is decreasing. You can see the situation is that the net force is towards right, and this will continue to move in that direction. For SHM, there should be that force and displacement should be in opposite direction, but here the net force and the x are in the, or displacement x, if I give a displacement x, they are in the same direction. So the body will continue to move in that direction. So this second charge particle minus q will continue to move along the x direction. So therefore, because here the net force is towards right, the particle will continue to move in this direction. This is the motion of minus q, and it is in positive x direction or negative x direction. If I would have displaced it towards left side, so it will be either moving in the right direction or left direction. So it will continue its motion in the directions of displacement. So if I see both this will not be happening. So suppose, see the option number 3, the charges Q will execute SHM, that we have found initially that the first charge executes SHM. First one, situation SHM, while the charge minus q will continue moving in the direction of its displacement. That means if I displace it towards right, it will move towards right. If I displace it towards left, it will continue to move in this direction. So whatever is the direction of displacement, it will continue its motion in that direction. So therefore, this option is correct option. That is option number 3 is the correct answer to this question. Thank you.